Hey guys, welcome back to Online Learning with Miss Gutierrez. I'm so happy to see you guys again. I miss you even more now. I know I said that last week, but I'm so looking forward to seeing your faces when we get together again for our Zoom meeting, and I hope you all can make it again. I hope your homework has been going well. I hope that you've been saving up any homework questions that you have for when we have our Zoom meeting together, because I would love to go over those with you guys. Anything that you're struggling with or anything that doesn't make sense, or maybe you had a question about something I said on one of the videos, please save those and ask me. This is Wednesday when I'm recording this actually, so that'll be tomorrow, but you'll probably watch this after the fact, so you get the idea. Either way, just be saving your questions for me. So today we're going to start with lesson 98. So this week you will be responsible for 3 lessons. I know, we always love that. So you'll have 98, 99, and 100. And then remember, you can still do the investigation as a bonus. So you always have that option. You might really want those extra bonus points right now. If it's too much with everything that's going on, then please do not feel like you have to do that right now. Okay, that is extra and not a requirement. So just keep up with your normal lessons that you have to do and getting those tests turned in and everything. And you guys are doing a great job. I'm so proud of you for pushing through with all the changes that are happening around us. And I know you guys are going to come out of this stronger. I think we all are. So let's get started. Okay, so today in lesson 98, we're going to talk about triangles and quadrilaterals and the sum of their angle measures. Okay, so I have drawn a figure here on the board. If we were together, I would say, who can tell me what this is called? And you may say a parallelogram, which you could be right. We don't necessarily have all the markings to prove that this is a parallelogram, but it is the general shape of a parallelogram. If you said it as a 4-sided figure, which is called if you're thinking quadrilateral, you're right, good job. That is correct. So this would be a quadrilateral, because a quadrilateral is any 4-sided figure. So we know that this shape right here can be considered a quadrilateral, whether it's an actual parallelogram or not. We know for sure that it's quadrilateral. Okay, so let's talk about a few of these things, properties that we want to look at here before we get into kind of the main points that we want to make in this lesson. Okay, so one thing to consider is that if you look at the quadrilateral, okay, we've got these angles inside. Okay, they're inside the figure, so we refer to them as interior angles. Okay, so I'm actually going to use a different color. Super exciting news, by the way. I got new markers. I'm so excited. So these are going to be your interior angles. I used one of my essential grocery trips to get my markers. So interior angles go inside the figure. Then if we extend the side, okay, so notice I'm just taking this side of the figure and I'm just extending it out. It's just an extension of a side that's already there. Then that outside angle that's formed is outside of my quadrilateral. So that is referred to as an exterior angle. Now, any given interior and exterior angle paired together, so the ones that are side by side like this, when you pair them together, notice they make a straight line. And if you look at these little angle markings that I've made, they form what looks like a semicircle or a half a circle. So if we know that a full circle is 360 degrees, we know that this measurement right here, a half a circle, is referring to 180 degrees total. So when you combine this interior plus this exterior angle, you're going to get 180 degrees. Okay, so we're going to say interior angle plus exterior angle equals 180 degrees. Okay, that also means we can introduce, well, you've heard this vocabulary term before, but we can reintroduce this vocabulary term of supplementary angles. So if these two have a sum of 180 degrees, any 2 angles that have a sum of 180 degrees are referred to as supplementary angles. Big long word. But again, it just means that they have a sum of 180. Okay, so angles that form a straight line, those are supplementary angles that have a sum of 180. Okay, the other thing that I want you to see here when we're talking about exterior angles, okay, so here I made this extension like saying if I were to keep going, okay? But what's really happening is that let's say that this is actually a starting point over here, okay? And this is gonna be, let's see, who can this be? Who in our class can this be? Let's make this Colin. We'll do Colin's. Colin, your hair looks so much better than that, but that's what I got right now. Okay, so here's Colin. Okay, so Colin's walking along and he's going down our little quadrilateral path, and then he's gonna come right here and he's gonna realize that he wants to turn to the left a little, okay? So he's making this turn, which means that this exterior angle right here is kind of being cut out from where he's going. Like that's an angle, okay? Then he's traveling this direction, but he's gonna make this turn right here, okay? So here's the exterior angle from that turn. So now he's walking along. If he were to keep going straight, he'd go that way, but he's deciding to turn this way. So there's another exterior angle. Okay, and so then he's gonna walk, and then all of a sudden, he's right back where he started. And so if he turns to go right back where he started, okay, then that will mean that he went in a full circle. He will have gone in a full circle to come back to his starting point. So all of those exterior angles that represent how much he turned each time, those are always going to have a total of 360 degrees because he went in a full circle. So they have to account for a full rotation. So all exterior angles of any figure always have a sum of 360. Okay, so the exterior angles of any figure, we're talking about polygons here, of any polygon, okay? So in this lesson, we're just talking about quadrilaterals and triangles. So in quadrilaterals or triangles, those exterior angles, the ones that are outside, so pay close attention to that, it's the outside angles, will always add up to be 360 degrees, okay? All right, so let's kind of switch gears just a little bit because I want to focus in on the interior angles real quick. We're almost done. Hang in there. You guys are doing great. So let's talk about these interior angles real quick. So we've learned, I want to show it to you kind of a little bit differently than the way the book does, just to give you a different representation. So you have learned that when you have a rectangle, okay, we know that a rectangle has 4 right angles. Each right angle is 90 degrees. So that means if I've got 4 90-degree angles, that is a total of 360 degrees. So the interior angles here have a sum of 360 degrees. So now we have also learned that if I make a line, a diagonal line that looks something like this, okay, can y'all see that? Yeah, I hope so. So if I make a diagonal line that goes something like that, it cuts my rectangle into 2 equal triangles. When that happens, now I've also cut my angles in half. So while I've talked before about how the area of a rectangle is equal, the area of a triangle is equal to half the area of a rectangle, right? So just like that, the angle measurements inside of a triangle are equal to half the angle measurements inside a rectangle. So let me show you what I mean. So in a rectangle, we have seen that area equals base times height, right? In a triangle, we have seen that area equals base times height divided by 2 because it's half as much as the rectangle, okay? So in a rectangle, your total sum of all your angles is always going to be 360 degrees, okay? If we have angle 1, angle 2, angle 3, angle 4, then we would say angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360 degrees. Now, if we have a triangle and we name these angle A, angle B, and angle C, then we could say angle A plus angle B plus angle C is equal to 180 degrees. Ooh, that's like almost cutting it off. Can y'all see that? There it is. Okay, so that is, I'll just hold it like this for a second so y'all can see it. That is true for any rectangle and any triangle. So they don't have to look like this, okay? It could be a triangle that looks like this. Okay, it doesn't have to be a right triangle like what these look like here, okay? Any triangle is going to have a sum of 180 degrees, and any quadrilateral, which is a four-sided figure, I used a rectangle because I wanted you to see the comparison of the area to help you remember the comparison of the angles, but it's any quadrilateral has to have a sum of 360, okay? So let's look at a couple of examples real quick so that you can kind of process this. So if we've got a lovely triangle like this one, and we know that this angle measure is 60 degrees, this angle measure is 70 degrees, and we want to know what angle A is. Well, this is a triangle. Any triangle has a sum of 180 degrees. All the angles in any triangle have a sum of 180 degrees. So I know I can add all my angles up. So 60 degrees plus 70 degrees plus whatever A is, because I don't know what that is yet, and it's going to equal 180 degrees. So to simplify that, I can start out by combining these guys over here. So 60 plus 70 is 130 degrees, plus A equals 180 degrees. So if I want to figure out what this missing one is, all I have to do is take that 130 away. So, because I know that it's got to be the difference between 130 and 180. So if I take that 130 away, then A has to equal 180 minus 130, which is 50 degrees. And that's how we figure out the missing angle in a triangle. Let's see if it looks similar in a quadrilateral. Last example. You guys are doing great. So quadrilateral, again, is any four-sided figure. So I'm going to draw one that it's not a rectangle. It's not a parallelogram. It's not even really a trapezoid. So this is just a quadrilateral, okay? It doesn't have any of those other properties, but it still has the truth that all the angles have a sum of 360. So if we've got this angle measure of 80 degrees, this angle measure of 80 degrees, this angle measure of 110 degrees, and then I'm looking for angle T, okay? Like I said before, this is a four-sided figure, so it is a quadrilateral, so it has to have a sum. All the angles have to add up to equal 360 degrees. So let's set that up. We know that 110 plus the 80-degree angle plus the other 80-degree angle plus whatever T is, because we don't know yet, has to equal 360 degrees. So again, just like we did before, we will simplify these guys over here. So I know 80 plus 80 is 160. 160 plus 110 is going to be 270 degrees. And if you weren't sure what that was, you could have just written it out and did the addition off to the side. Okay, I'm just trying to kind of keep things moving here so that we can finish up. Okay, so then if I want T by itself, I just have to I just have to figure out, okay, what is that difference between 360 and 270? So that would mean subtracting that 270 to find out what T is. So T then has to be 360 minus 270, which is 90 degrees. And that's it. That's all for this lesson. So the main takeaways that I want you to remember are that triangles, first, back up. Any figure has a sum of the exterior angles. So not these inside ones, but the ones that were formed on the outsides. Remember when we made those lines? All the outside ones add up to be 360. Okay, so keep that in mind. But then the main thing that we focused on today is interior angles. So a triangle has a sum of 180. Good. I know you said it in your head. I know it. And then the quadrilaterals have a sum of 360. Awesome. I know you guys are saying it. I know you're getting it. I totally believe that because I know how smart y'all are. So happy homework, and I'll see you back on lesson 99. Bye, guys.